Welcome to my channel RPS videos. Thanks for your support. Let's start the today topic spherical mirrors. As so far we discussed plane mirror or the reflection of light on a plane surfaces, and we discussed plane mirror and image formed by the plane mirror and the characteristics of image formed by a plane mirror, right? Does light reflect or reflect only on plane surfaces, or does the light reflect or any type of other surfaces, any other surfaces, right? So as we know, if it is the plane surface, the light is incident and reflect. Such phenomena is called reflection of light. What will happen if the surface is like this? What will happen if the surface is like this? What will happen if the surface is like this? What will happen if the surface is like this? On these surfaces, can the light reflect or not? Absolutely reflect. Absolutely reflect. Up to here, we discussed reflection of light on a plane mirror or on a plane surfaces. Do all the reflecting surfaces are plane? Do all the reflecting surfaces are plane surfaces, or have any other surfaces? Other surface? Absolutely have other surfaces like spherical surface, right? When a parallel beam of light incident on a plane mirror, let's consider it is a plane mirror. If a parallel beam of light incident on a plane mirror, on a plane mirror, we can say it is a beam of light, right? It reflected as a beam of light. Okay, so after reflection, after reflection, for example, sorry, this is a light ray incident and reflect. This is the another light ray reflect, and this is the under light ray reflect. This is the under light ray reflect. So these all are the normals. In the light incident on a plane surface like a plane mirror, we observe that these all the reflected rays are doesn't meet at any point. No convergence, no convergence or no divergence. They won't meet at any point, they won't diverge from any point. So you can said to be um, no diverging of reflected rays, no converging of reflected rays. So on plane mirror, if a parallel beam of light is incident on the plane mirror, after reflection they reflected parallelly only. Such kind of reflection is called regular reflection. Regular reflection. Then what will happen if a light incident on a curved surfaces? Curved surfaces are spherical surfaces. So let us understand reflection of light on curved surfaces. Let us understand this reflection of light by using spherical mirrors. Spherical mirrors. And on a plane surfaces, the light incident parallelly, they reflect parallelly. What will happen if the light incident on a curved surfaces or a spherical surfaces? For understanding, let us know what are spherical mirrors. So a spherical mirror is that mirror whose reflecting surface is the part of hollow sphere of glass. Hollow sphere of glass. A spherical. So imagine that a sphere. Imagine that a sphere. Right. This is a sphere. This is a sphere. Imagine that. If light incident on this surface, it is not a plane surface. Both sides, it is not a plane surface. If a light incident on this kind of curved surfaces, what will happen? What will happen? Let us understand what is. So, we will discuss the reflection of light on a curved surfaces with the help of a spherical mirror. A spherical mirror is that a mirror whose reflecting surface is the part of hollow sphere of a glass. Hollow sphere of a glass. Imagine that a sphere. If I cut into two halves, or if we cut in any part of a sphere, right, it gives, it forms, it gives this kind of structure, right, reflecting surface. Observe that reflecting surface, reflecting surface is the part of a hollow sphere of glass. Hollow sphere of a glass. This is a sphere. If any part acts as a reflecting surface, that part, that type of mirrors are called spherical mirrors. When we cut in two halves, if the light is incident here, hollow sphere, any part of the hollow sphere, either it is the outer part, or either it is the outer part of the sphere or the inner part of the sphere, hollow sphere, such kind of mirrors are called spherical mirrors. Based on the reflecting surface, based on reflecting surface, there are two types of spherical mirrors. One is concave mirror and other one is convex mirror. One is concave mirror, then other one is convex mirror. What is this concave mirror? Concave mirror. So, concave reflecting surface. If the plane mirror, sorry, if the spherical mirror has reflecting surface inside, reflecting surface is inside, then we can call it is concave mirror. That sphere, if the sphere is divided into two halves, one is formed hollow, the other one is bulged out. Bulged out. So a concave mirror is a spherical mirror in which the reflecting light, reflection of light takes place. Where the reflection of light takes place? Inside. Inside the hollow sphere. Inside the hollow sphere. light is incident here. This is the surface. From here, when the light is incident here, then the light is reflected. The surface is how? Like a cave. Like a cave. Inside, like a cave. So, such kind of mirrors are called concave mirrors. Concave mirrors. Reflecting surface is like a cave. Reflective surface is like a cave. That's why it is a concave mirror. On a concave mirror, the reflecting surface is hollow, inside the hollow. So, light incident and reflect. Such kind of mirrors are called, such kind of mirrors are called spherical mirrors or a concave mirror. Whenever we turn the other side, mean this is the bent in surface, bent in surface. Then coming to the other side, this is the part of hollow sphere. This is the part of hollow sphere. What is spherical mirror? If the reflecting surface is either inside or outside. First, if the reflecting surface is inside, then we can call it concave surface. Such kind of mirrors are called concave mirrors. If the reflecting surface is outside, the reflecting surface is outside, such surface is called convex. Those mirrors having a convex surface for reflecting light, such kind of mirrors are called convex mirrors. Inside the reflecting surface, concave, outside the reflecting surface is a convex. So here the concave or the convex, both are the part of a sphere only, part of a sphere. So if it is a sphere, hollow sphere, then when we cut into two halves, we observe that inside reflecting surface, outside reflecting surface. Inside reflecting surface is called concave surface. If the mirror has a concave surface, it is called concave mirror. If the mirror has outside reflecting surface, can called convex mirror. So in case of this concave mirror, in case of this concave mirror, so this is an example for concave mirror. So let us consider if it is a sphere. If it is a sphere, when we cut into two halves or when cut into any part of the sphere, it forms like this. This is cave. Cave is appear as a cave inside hollow space, inside hollow sphere, cave. So this is example for concave mirror. Then it is in which side the reflecting surface outside. This is inside. This is outside. So this is called as convex surface. Convex surface, concave surface. So those are called concave mirrors as well the convex mirrors. Bent in surface, bent out surface. Plane, bent, bent in, outside of bender, inside bender, inside bender. You see this part is a concave reflecting surface, concave reflecting surface. If I bent out, if I bent out, if I bent like this, reflecting surface is outside. For example, like this, right? Plane mirror, right? So what will happen? Cave inside, concave. The other part is concave. One is if I bend like this surface is acts as a convex, sorry, concave. The other part is acts as a convex. So bent in surface is concave mirror, bent out surface is a bent out surface is called as a convex mirror. So whenever we observe the spoon, we have to observe both bent in surface, bent out surface. Bent in surface is concave, bent out surface is convex. So if the light is incident on any plane surface parallelly, what will happen? They won't converge or they won't diverge at any point. But in case of this spherical surfaces or curved surfaces, maybe maybe the maybe the light rays are converge, maybe the light rays are converge, maybe the light rays are diverge. Maybe the light rays are converge, maybe the light rays are diverge. So in this way, this is the incident rays. These are the incident rays. These are the reflected rays. Reflected rays are all diverging. So when we extend back, they diverge. Here, all are the incident rays. All the reflected rays are converged at one point. But in case of plane mirrors, no reflecting rays are cannot be converged and cannot be diverged. In case of spherical mirrors, maybe maybe the reflected rays are converged at one point, to diverge at any point. If they converge, you can call it concave surface, concave mirror. If they diverge, we can call it convex surface. Example, convex mirror. Example, convex mirror. So this is concave surface, hollow, inside the hollow surface, outside the sphere. Inside the hollow sphere concave, outside the hollow sphere convex. Convex surface, concave surface. If the mirror has bent in surface as the reflecting surface, we can call concave mirror. If the mirror has bent out surface as a reflecting surface, we can call as bent out surface. We can call convex surface. If the mirror having bent out reflecting surface, we can call this convex mirror. So these are the two types of spherical mirrors. One is a concave mirror, then other one is the convex mirror. One is concave mirror, another one is the convex mirror. Keep in mind, in case of plane mirror or plane surfaces, reflecting reflected rays are cannot converge, right? When you extend them back, they may be diverged back behind the mirror, right? But in case of concave and convex mirrors, in case of concave mirror, all the reflected rays are meet. In case of convex mirror, all the reflected rays are can diverge from one point. So, spherical mirrors works on the reflection of light.